this video, I'll try to explain about stack. Stack is a last in, first out data structure, one of the simplest and most used among data structures. The most relatable example is your browser history. It stores the pages in a stack. When you browse a page, suppose a stack is initialized and moves further on, browsing more pages. You can observe here last in element will always be on the top of the stack. Stack has two fundamental methods. One is push. Suppose you're pushing an element E. That element will be stored on top of the current top position and it will become the new top. The one more method is pop. It will delete the last in, that is the top element, hence top comes down and it returns the deleted element, hence the name last in first out. Stack doesn't come with Python as a built-in data type. Even though stack has only two fundamental methods, pop and push, I will implement three more methods for my convenience. One is top, which returns top element. If the stack is empty, it will return error. Pop also behaves the same. The other one is empty, which returns true if the stack is empty. Considering our example, it is false here. The one more method is len, which is used to return the length of the stack. You can see here len is a bit different from others. It will take the stack as an input rather than acting on it. So I will show the implementation in a bit. Let's see how to implement stack in Python. Suppose if I bend the stack horizontally, it resembles Python's list. The append and pop functions or methods of Python's list can be used as push and pop of stack. The -1 index will always return the top element required for the stack. But there is one problem. If we access the list using index, that will violate the stack's implementation. Hence we need to follow adapter method and create a class which will only restrict required methods. Before going to the implementation, let me show you how the stack's methods are implemented using Python's list. Suppose take push will be implemented using append. Pop will have the same name in Python's list. Top will be implemented using -1 index. Empty is implemented using length logic, and len method of stack will be implemented using len function of list. So the class array stack will be defined and you can just initialize the stack using array stack class and you can use these methods. I mentioned earlier that top and pop will return errors if the stack is empty, but Python's list will return index error when the list is empty. So we need to define a class for exception and pass the exceptions when needed. So I have defined a class for the exceptions and inside that I have just passed it. So moving on, this is the class which we are implementing using Python's list. So the array stack is defined and it has the first method, init method. So when you define an object of the array stack class, the data element named as data will be initialized, that is a list. The second function is len _len_. This is a special method. Whenever you call len of some data structure, this internal method which has two underscores before and after will be called inside the class automatically. So inside this method I have defined return len of the Python's list. Moving on, the third method is isEmpty. Here I'm returning the logic. When alien is equal to 0, it will return true. Moving on, push is implemented using append method of Python's list. Top is implemented. As I said, I need to handle the error here. So if the stack is empty, it will raise an exception with the message stack is empty, and our empty class, which is the exception class, will pass this exception. So you can define your own exception classes however you wanted and log the issues. And finally, if it is not empty, it will return the -1 indexed element of the list, which is the top of the stack. The last method is pop. So here also, if the list or the stack is empty, it will raise an exception, but it will handle the index error of the Python's list. So if it is not empty, it will return the self. It will actually execute the pop method of Python's list, and the pop method will always return the deleted element, and that deleted element will be returned as a return value of this pop function. So analyzing the implementation, we can see here all the methods of stack. That means our array stack class will have constant time in big O notation, but push and pop sometimes take more time depending on the size of the stack. So after hearing all this, you might imagine how to reverse any given data using a stack. It is very simple. Suppose you have a list or group of numbers 1 2 3 4 5. You want to reverse the numbers and make it 5 4 3 2 1. You can just push the elements of 1 2 3 4 5 one by one into the stack. Hence the stack is built up on top of one on top of another one. The last element will come on the top. Then you can just pop one by one and write it to make the data in reverse.